I really love my 3D printer for what it can do. But the one thing I actually really want to do is produce metal parts. The solution? Tabletop CNC mills. But those have a huge learning curves and you need months and months to master. Or do you? Can you master this in less than 1 hour? We are going to find out today because we try to teach a newbie within 1 hour to use all the processes on a CNC mill. And we will dive into the technology of CNC milling and explore together how hard it is to learn and what are the differences to 3D printing. So follow along. Desktop CNC mills like this one are all over social media right now. I see advertisement after advertisement calling it the next big step in home manufacturing. And of course, the big versatility in materials and tools you can use with it is promising, but also the learning curve of it is daunting. But Makera actually gave us this Carvera Air and they promised that with this machine you can learn CNC milling kind of as easy as 3D printing. Of course, we're comparing early days 3D printing where there was a lot of fidgeting around because a CNC mill is never as easy as a 3D printer itself, but you can get very close. So first of all, let's have a look on the machine. I think it's very well built, it's strong, it has like no slip in any of those axes, and it actually has a fairly decent sized motor. And I also got the dust unit where it can suck the dust out of the way with this like nice dust shoe that you can click on here with magnets. Also, this is the Carvera Air because it actually has an air hose and you just buy a little pump and you can do your chip evacuation by that. But also, this machine comes with loads and loads of extra gear and tools. So basically, they promise they deliver everything you need to start right away without buying anything else. So instead of just telling you about the features and what it can and can't do, let's look at some examples. Then I will mill a little part together with you just to show you the capabilities and how tool changing works, because yes, it can actually tool change in the middle of the process without an automatic tool changer. And I think that's a really, really good feature that this machine has. I shouldn't be the baseline of this test. So first of all, we of course have to create our data set. We're using CAD software, and there is already the first difference between a 3D printer and a CNC mill. In 3D printing, you work from so-called STL files, which are tessellated files that have a volume and a polygon and a normal, and this creates a 3D volume. In CNC milling, you actually work from so-called STEP files. STEP are a universal language between construction software or CAD software, computer-aided design software, that gives you true full volumes and straight curves and everything that is crisp, basically. So the program itself, you could call it Slicer, but in that case, it's called a CAD-CAM software, computer-aided manufacturing, will actually write your G-code for the machine. It's the same G-code you use for a 3D printer because that G-code actually derives from CNC milling or NC milling. So up until here, they're very, very similar. They give you quite an extensive assortment of bits to choose from, but this is the next big difference to 3D printing. In 3D printing, you actually think about one thing, mainly. It is material. So the spool that you put into your printer that comes out of your nozzle and builds your part from the ground up. But here, you actually have to remove material, and to remove materials, you need to use tools. Of course, you could just go for a small and tiny one and just do millions of passes to get like super high accuracy. But that is kind of like printing with a 0.1 millimeter nozzle if you try to manufacture a chair. It will take ages. And also there's some stuff a simple straight tool can't do. For example, a chamfer or a thread. And so for this, you actually have a lot of different tools. And that's kind of like the thing you have to learn is to figure out which tool to use for what. And there's also different tools for different materials, but we will get deeper into that later. And after that comes, in 3D printing, normally slicing. In our case, now comes the CAD-CAM operation. So from CAD, computer-aided design, CAM means computer-aided manufacturing. So basically the slicer of the CNC world. You are actually very free on which slicer or which CAM software you use. Makera actually came out with their own CAM software, which I really like because all the tools you have in here and all the main materials you can buy from them are already pre-configured. Because there is the next thing that differentiates 3D printing and CNC milling. Every tool has a different setting. That means by material. So a tool that can go 5 millimeters deep into the material and travel with 100 millimeters per minute through a material like resin can't do the same thing in metal. So traditionally you needed to know all those values or needed to know where to look them up. But with all those prepared bits, with at least the material they already pre-tested, all of this is filled out. And this makes the learning curve so much better when it comes to this specific machine. This software is the CAM software of Makera itself. It's called Makera CAM, duh. And at the beginning you have to choose if you want to work with 3 axes or with 4 axes. So yes, they actually have a 4th axis. It's this little guy. It's a motorized spindle where you can actually put in a block of material. For example, this was manufactured with it. Makera actually gives you, when you buy the machine, loads of like test pieces just to get familiar with the machine. And you simply put it in and the mill mills while the part spins. So that's the 4th axis. So the 3 axes work like a 3D printer works. And this one is actually kind of like a bed slinger, but that's normal in metal manufacturing or in like mill or flat mill manufacturing. Because we don't drive with the speeds a 3D printer does. We don't have to because we can remove more material that a 3D printer can add in one go. So wobbling isn't really a problem. Also, you have to clamp your part down. It needs to be secured because a CNC mill, while cutting, actually has lateral forces. So if you don't secure your part, you will just move it around. Or because this spindle goes really fast, thousands of revolutions per minute, it will actually just spit out your part into your face or into the hood, which you hopefully closed before. So when it comes to processes of manufacturing something, you actually have a limited way of doing stuff. So in here, for example, you have a 3D relief, a 3D pocket, 3D contour, drilling, chamfering, and a thread. So the thing is, the 3D relief is actually the only thing you can use when you work with an STL. So something like that you can manufacture with an STL. What it will do, it will follow the STL lines like a 3D printer would when it would move in 3 axes. And this is actually what I really love about CNC milling. Surface-wise, CNC milling will be a great step up in quality of your part. Cutting direction. So this is something I want to take a little time to explain because it's very important. So while you drive through your part, you can do one of 2 things. Either you can drive into the blade and really get material out, or you can drive with the blade and actually scrape that way. So what it does, it actually changes how your waste, your chip looks like, and where the big side and where the small side of the chip is. And this has direct influence on the surface quality you leave behind. Climbing is always better as conventional because climbing gives you nicer surface quality, but it also stresses the machine a lot because your bit is actively trying to pull in the way of movement. And if you go against it, it actually pushes against the motor, so it's very stable. We now have to prepare our machine. This can look daunting for a beginner because there's a lot more going on than in a sleek, modern 3D printer. But instead of a nozzle just simply heating up material and pushing it forward, we have a spindle that spins a tool. And of course, those spindle speeds and stuff like that is something you have to find out for your specific material. I mean, there is loads and loads of sources for hundreds of years of research on subtractive manufacturing that came up with speeds and cutting forces and everything and plunge depths for nearly every material out there. But of course you have to test it yourself. But let's be honest, in the beginning of 3D printing, we did the same with plastic. We set temperatures, we set feed speeds, extrusion multiplier, printing speeds. So this is kind of the equivalent. And I'm fairly sure this will improve a lot in the future. That materials actually can be somehow automatically tested or you just buy the standard material of your supplier. You can just take scrap from anywhere, be it wood, be it leather, be it carbon fiber for drone building, be it metal, be it aluminum. You can just throw it on there. As long as it fits, you can just manufacture with it. So the machine beeped and it actually tells me what it wanted to have from me. So what should I do? It tells me, please put in the touch probe. So actually let me remove this dust shoe real quick so the probe can go in, and this probe is simply attached to your machine. And over here you have a little lever. You push that lever down and it actually opens, and then you can put your tool in, it closes, and then you simply say, I'm ready, or press that button up here. So while our machine is working away on our test parts right now, let's answer the question we asked in the beginning. How hard is it actually to learn a machine like that? For that, we had a little bit of an experiment. So let's meet my friends. So to see if it's really that easy to learn like they claim, I brought two of my friends here. Both of them have varying degrees of knowledge about classical manufacturing or subtractive manufacturing. The goal today here is actually to teach you guys how to mill in below 1 hour and then see if this machine survives you. So maybe you introduce yourself real quick yourself to all the guys, and you might already know him.
My name is Ruben. You may remember from some of the previous videos. My background is in electronics engineering and robotics. I have mostly worked with 3D printing technologies and making 3D printed parts, but of course during my education I had some basic notions about subtractive manufacturing, milling, and let's say a little bit of the CAM software, but really very basic. Never really used milling machines on a, let's say, regular basis.
So he's basically someone you would call an intermediate user of this machine. And now to Till.
The complete idiot. But yes, hi everyone, I'm Till. My background is in biomimetics and then also biomedical engineering, but I was focusing a little bit more on the material science, I would say. I have some experience in 3D printing, so I've been using it as a tool to do my parts and so on, but CNC is really the first time for me today, so you can say I'm a really first-time beginner. Let's see how it goes today.
So I would say let's dive right in. I will structure it a little bit for you guys. So we will first go over material itself, then over tools, then over tool settings, how to create tool paths, and then how to use the machine. And at the end, you actually brought your own little project you want to mill, and let's see how that goes. We start simple and go deeper and deeper into it, but I will restrict myself to 1 hour teaching time. And while they are using the machines on themselves, I will not intervene, even if it's about to crash. We actually have an emergency button on this machine, which I think will be helpful later, maybe. And I have to say, it's one of the most beautiful emergency buttons I ever saw. So I'm looking forward to pressing that. So let's dive right into that. We have time till 8:26 maximum to make that work. Okay, let's start with the basics. Stock. So when it comes to 3D printing, you normally have your filament on a spool. How deep it can go in one cut, in which material. It's the diameter, and the second number is always the length of the cutting edge. Okay, so leveling up and going down. Milling is. It's underneath. Exactly. But just polish at the end.
Yeah.
An extrusion from. Now we are actually finished. Here is our war trophy, I would say. We actually did a second one, the test one, and I crashed it. So well done, Till.
It was surprisingly easy to set up the whole software and start to print. This I could remember.
Not a print.
The yes, the milling job, or how would you, or else would you call it? Yeah. Now then, if it somehow something doesn't work like you intended, it runs into a problem, or it gives you an error, then I'm not sure if I would be capable of resolving this error by myself, to be honest. There I did have to rely on you. Now would I buy the machine? So I don't even have a 3D printer at home, so I think this would still be my first material of choice, but I do believe it's a pretty cool machine. So yeah, it was fun as well, to be honest.
So from my side, I see the machine as kind of like let's say the equivalent of what Prusa sort of were for 3D printers. So I think it's a really cool device. It's very, compared to, let's say, the industrial CNCs, also Andy, you have experience with this, compared to let's say the industrial rated milling machines. It's really easy to use and really easy to get introduced into it and to get started. The software really guides you through everything. The fact that they have their own tools that you can use, and they already have preloaded all of the feed rates, all of the turning speeds and so on, which is usually the really tedious, really effortful thing to do with this type of machine. So figuring out all of these parameters is really, really well done, and it's really simple to use. So in that sense, I think it's a huge leap. But in terms of, let's say, would I get one of these, I would first also go with the 3D printer. I don't think it would be able to replace it. But if you have the place for it, if you have the budget for it, I think it can be a really cool addition to, let's say, your tool inventory for making very precise parts or in metal and so on.
Okay, so how nervous did the machine make you when it drove towards the part?
6 out of 10, not as much. But I did have my finger on the stop button at all times in the beginning.
That's actually funny because I have like 2 decades of experience and I get super fucking nervous. But that's probably because I saw some heavy crashes before and I know what can happen, and that sometimes you just mistype something and that thing just auto speeds into your part. Okay, great. Then thank you guys for helping out with learning this machine. And yeah, I guess we talk a little bit more about the machine itself and what you can and can't do and what is still missing. But for now, thank you guys. So about the machine and the process itself. Of course, I'm biased. I love CNC milling or milling in of itself because of the surfaces and because I can do metals. So the versatility of this, mwah. Also about the machine itself as a unit, I think it's a very well-designed product. It is easy to handle. So my verdict on, is it as easy as 3D printing? Of course not. I don't see these machines be in every workshop and every home like a 3D printer actually is now. But CNC milling is way more of a serious manufacturing technology and normally unreachable because of price and complexity so far. So I think this is a step into the right direction. Shit. Okay. For that I invaded some friends, yes, like. Shit. Allergic to work, you know. Oh, we're still rolling. I love my channel.